Okay, so today we are talking about Leetcode number 2414. One of the newer problems of Leetcode. There's probably not that many like good videos out about this problem, and this problem is called length of the longest alphabetical continuous substring. As you can see, not many people have really tried it. Only 438 thumbs up, 27 thumbs down. Don't know what the 27 we're talking about because it's actually a pretty good problem to practice, especially if you're thinking about doing sliding window. Okay, let's start. An alphabetical continuous string is a string consisting of consecutive letters in the alphabet. In other words, it is any substring of the string A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So basically, the whole alphabet, this is the longest continuous substring that you could have for any input that they put in. Because this is not circular, right? As in after Z, if you put in A, it doesn't count as 27 as the longest alphabetical continuous substring. And then they give us a little example. For example, ABC is an alphabetical continuous substring while ACB and ZA are not. As I said, it's not circular, so it can't be ZA. And ACB, C doesn't come after A unless there's a B in it, right? So A, B, C, D, E. So basically, if it's part of the alphabet, then it is a continuous substring that is alphabetical. And then given a string S consisting of lowercase letters only, return the length of the longest alphabetical continuous substring. So in these examples, we have A, B, A, C, A, B, A. So A, and what comes after A? B, right? So this is already an alphabetical substring because it's an index of that right here. Then we have AC, right? So since it's A right here, this substring no longer could go more to the right, right? So right now, our longest continuous substring is 2, right? Because A and B. And then it resets after we get to A because it's not C, right? But if it was C, we would keep that window going. So I took this example on the left and put it on the right just as a little visual on how we're going to approach sliding window with this problem and how we're going to resize the window every time we don't have an alphabetical continuous substring and every time we do have an alphabetical continuous substring. So as we could see, as we said, A to B, that is 1, right? And then once we get to this right side right here, this is not a C, right? Because an alphabet, it goes A, B, C, as we learned in like kindergarten, right? So once we reach this A, this window stops, right? Because we have A, B, which is continuous, but then there's no C, so we stop the window. And then we take the length of this window, right? We take the length of this window, which is 2, and we keep track of the max. So this is an O of n squared. It's not like we go from each letter to each letter to each letter for each letter. We'll go from this window, and once you reach the end of this window, we're going to resize the window starting at the end, right? That might seem a little bit confusing, but here, let me show you. So we ended at AB, right? So that's one window. So now our new window is going to start from A. Is A an alphabetical continuous substring? Yes, right? It's of length 1. Now let's go to the next one. Is AC an alphabetical continuous substring? No, it's not, right? There has to be the B in the middle. AC is a subsequence, but it's not a substring. Our length for this one is 1. Our length for this one is 2. And as we're doing this, we're keeping track of the longest substring, right? So our max between these two so far is 2, right? So now we start at C, we go CA, nope, does not work, right? So now we ended at C, this window is length 1, is 1 greater than 2? No, it isn't. So now we start at A and we go to B and look at this, we have 2 again, but if we can't go anymore because it is not a C. So we close that off now and this is of length 2, and now since this is the end of the array, it is of length 1. So our max will be of length 2, which is AB. We take a window and we resize it every single time we get disrupted in our alphabetical continuous substring. And we make it bigger for each letter the alphabetical continuous substring is there, right? And once we reach the end of that alphabetical continuous substring, like let's say like in this case there wasn't a C here, right? And we had to end the window at B. We take the length of that window and see if it's our max, and if not, then we just continue. If it is, then we update our max. Okay, so there are multiple ways to see if the substring is alphabetically continuous. Like there's the brute force way, which many people have done, and then there's the ASCII way, which a lot of people have done, ASCII, ASCII, whatever you want to call it. And in this case, I'm going to do the ASCII way because of how much easier, and in Java's case, how much ultimately better it is. Because let's say you do the brute force rate, right? In this case, you would take this AB window, and each time you resize it at a bigger length, you'd be saying, is this an index of this big string right here? So we'll start at A, right? Is A an index of this big string right here? Yes, it is. Is AB an index of this big string right here? Yes, it is. And is ABA an index of this big string right here? No, it isn't, right? Because it goes ABC. But in Java's case, you would have to scan this whole string each time you resize this window, right? Which is just optimally, it would take a lot amount of time compared to the ASCII way. So basically, the ASCII is a code for every letter in the alphabet. They also have it for other special characters and numbers and everything. But since like a computer could only read zeros and ones, and ASCII code is basically their representation in code. So for the letter A, the ASCII code is 097, right? And the letter B is 098. Letter C is 099. Uppercase A is 065. But remember, we don't have to worry about the uppercase because they said it will all be lowercase letters. But what do we see the pattern here? So A is 097 and B is 098. So it's literally just one after the other. It's plus one each and every time. So basically in the sliding window, we're going to keep track of our previous letter and see if the letter we're currently on is plus one their ASCII code. Let's say we have ABA in this case right here, this whole string right here. So we start with A, 97, right? Which is already good, right? Because one letter is alphabetically continuous. Then we have B with the ASCII code 98. So that's plus one, so we're good. And now we're not C, but now we're back at A at 097, right? And since our current letter is B, since we're at B right now, right? We're at B right now. And now we're looking at our next letter A. 097 is not 098 plus 1. It would have to be 099, right? So that is where we end it, and then we go back to C. So here we have another example, A, B, C, Z, D, E. Here, I'll put my Z like this because some of you like that, right? So we're going to start at A, and that ASCII code is 97, and one letter is alphabetically continuous, right? So that is fine. Now our window is at AB, and now we're at 098. So is this ASCII character minus one of this character? Or in other words, is the B's ASCII code one more than A, right? So A is 0.97 as we could see, and B is 0.98, right? So now, yes, it is. Now we go to our next window. This is now our previous letter. So B is now our previous letter, and C is now our current letter. So is our current letter ASCII code one more than our previous letter's ASCII code, right? 099 is plus one than 098, so it is. But now we're at Z, and Z's ASCII code is 122, and C is our previous letter, Z is our current letter, and it is not plus one than 099. So now we end that window. We take the length, which is 3. We're at Z now, and we take Z and D. And as we know, the ASCII characters or ASCII codes aren't plus one. So now we end that window, and now we have D and E. And D, as you can see, is 100. E is 101. And that is our length of 2. But our max is now 3 because of our A, B, C. So people really overlook the ASCII table. And in so many situations, it'll be ultimately better because in code, it is built in like that, right? So if we have the letter A as a character, right, and we cast it to an int, it will have the number 097. If we cast the letter capital E to an int, it will have the number 069. Okay, so this is my Java code for this problem, right? So this is a sliding window, right? So we have a start integer, we have an end integer, we have a max of 1 because even if the string is of length 1, remember one letter is alphabetically continuous, right? So our max will be 1 no matter what unless the string is of length 0. So now, as I said, we're going to have a previous letter and a current letter, right? Our previous letter, we're going to start at char equals 0, right? So this one will be, I'm going to put it as P. And then we're going to have a current letter, which we'll use later. So we'll start our while loop at end is less than s dot length. So that is basically our edge case, right? So once end is out of bounds, then we'll stop this whole entire loop. Our current letter is at s dot char end, right? And end in this case is 1, right? So this will be end. We'll put it with the E. All right, so that is our end, right? So while end is less than s dot length, and remember when I said the ASCII character, it is as easy as this, is just casting the current letter to an int, right? So our current letter is at B, and I think that's ASCII character 98. So if 98 is equal to the previous letter plus 1, which is A, which is ASCII character, because we cast it to an int, 97 plus 1, then the previous letter equals current letter. So once we satisfy all our conditions in this while loop, we'll keep going until this while loop is finished. And then we're going to restart our window. So this is our window when it keeps increasing. And then once it stops increasing, we'll go out of that while loop and check our max. As I said, this is when we reset the window. So everything in this is if it is alphabetically continuous. So since we do satisfy this equation for our first two letters, we're going to put previous letter equals current letter. So this isn't previous anymore. This is previous. And then we're going to increase the end. So now end is going to be equal to 2. And if end does not equal s dot length, then current letter equals s dot char at end. This statement right here is just a little edge case at the end, is that since we're incrementing our end, there is a chance that we could go out of the string, so out of bounds. So this does check if it is there. And if it is out of bounds, then we're going to leave this while loop. And then we're going to come here and then we're going to leave this while loop since we're going to not satisfy this equation, right? So it's just a little edge case just to check if the end, once we increment it, is out of bounds. Since end is now at 2, our current letter will be s dot char at end. So this is now going to be our current letter. All right, so we're going to do the same exact thing until we reach a point where it isn't alphabetically continuous. So now we're at C. If end is less than s dot length, which it is because it is at 2, and int current letter, in this case it's C, which is 99 ASCII character, equals previous letter plus 1, which is B, which is 97 plus 1. If they are equal, then we're going to go through this whole while loop again, and we're going to keep doing it until we reach the end of the alphabetically continuous substring, right? So this is our substring right now, and once we reach Z, it is going to break out of that while loop. So once C is the previous letter and Z is the current letter, then we're going to break out of it and we're going to check our max. So as we said, since B and C are alphabetically continuous, we're going to increment end. End is now going to be 3. We're going to check if it is out of bounds, which it isn't. Our current letter is now going to equal end, which we did over here. Z is now our current letter. And now we check again this condition. As you could see, it will not satisfy it since Z does not come after C. So we're going to leave this while, this inner loop, while statement, while loop, and we're going to check the max. Remember the max is 1, right? And this is the first time we're checking the max. So which is bigger, max or end minus start? We're checking the length of our window. So our end is 3 and our start is 0. So 3 minus 0, our window is bigger than the old max. So now our max is updated to 3. Our start equals our end. Our start equals our end, which is now 3, and end is now 4. So now the new window is not A, B, C, but it's actually Z and D right now. Our new window is Z and D, And as you can see, we're going to go through this again. It's not even going to go through once. Our max will not be updated. Our start will equal our end again. It'll be 4. We're going to increment our e to 5. And now we have another window, 4 and 5. And as you can see, it is alphabetically continuous. But once we reach the end of the string, the window is only of size 2. So our max still stays at 3. That's an ugly A. Our max still stays at 3, right? And we return the max at the end. So this is a sliding window approach, which Leetcode has a lot of practice problems on. And the related topics that they said for this problem was just string. They didn't even put sliding window for related topics. But sliding window is very optimal. And once you add ASCII characters to this and not index of or brute force way, I feel like this is a very optimally great way to approach this problem. And if you have any questions, put them down below.